Hey guys, I hope you all are doing good. In the last lecture, we completed functions and we completed the first section of our playlist, right? So in that section, we covered sets in detail, then moved on to functions, understood tuples, and a lot more things, right? This is a brand new section and this section is going to be based on understanding logic, right? So this section will include three different topics. We'll understand what is propositional logic, move on to predicate logic, and then also understand how we find proofs, right? So this is going to be a very important topic to understand. So let's start with what is a proposition, right? A proposition is a statement that is either true or false, but not both, right? So just a very simple definition that we have, right? If there's any sentence or there's any statement that you have which you can either declare that it's either true or false, it basically means we can say it's a proposition, right? So for example, 2 plus 2 is equal to 4. Let's think about it, right? We know that 2 plus 2 is in fact equal to 4, right? So I can say this is actually true. And since I can declare this as true, this is actually a proposition, right? Okay, let's think about the second one. Second one says 7 is a prime number. Think about it. Is this true or is this false? We can find out either one of the two values, and this is actually true in this case. So, since the statement is either true or false, I can say that this is again a proposition, right? So this is a proposition, this is a proposition. Now the sky is green, right? Now I don't know if this is actually possible or not, but in like normal scenario, this is not possible, right? The sky is actually blue in color. So that's what we mean, right? But so in this case, this is going to be false. But the basic idea is that I can actually figure out that this is true or is this false, right? All of these three different statements that we have, they can either be true or they can be false, and that is why all of these are actually propositions, right? Now let's take a look at some of the statements which are not examples of this, right? So for example, what time is it? Think about it, right? Do you think I can say whether this statement is true or not? What time is it? I cannot say if this is true or not, right? So this is not a proposition, it is actually a question. So a question, right? Do your homework, right? This basically means, okay, do you think I can understand, or do you think there's any true or false value for this statement? There is none, right? Why? Because this is basically a command. I'm trying to tell somebody to do something, but this statement doesn't have any true or false value. So this is going to be a command over here, right? Now let's take a look at the last example, which is actually not a proposition. So now the example is x plus 5 equals to 10. Now a few of you might think that this is actually going to be a proposition. But let's try to understand one thing, right? Unless I'm given the value for this x over here, I don't know whether this is going to be true or false, right? So it can be that x is 1, in that case it would be false. And if x is 5, in that case the statement would be true. So only in the condition that I have the value for x will I be able to figure out whether this is true or false. But in general, this is not a proposition, right? So the basic idea is very simple to understand. If you read a statement and you know that it is either going to be true or false, like it has one of the two values, true or false, then I can say that it is going to be a proposition. Otherwise, it's not, right? So there's three basic types. If it's a question, then it's not going to be a proposition. If it's a command, it's not going to be a proposition. And in equations which involve variables, right, and we don't have the value for those variables, for example, in this case, we don't have the value of x, again, this is not going to be a proposition, right? Last thing, we represent propositions using capital letters, right? So basically what happens is, in our case, when we are going to be solving equations or solving more complicated problems, we usually say that, for example, A is the proposition, good, Y, right? So we basically represent them using capital letters. Now think about this. Is this a proposition or not, right? Now it does have true or a false value. he can be a good boy. If he is, then this is going to be true. If he's not a good boy, then this is going to be false, right? So moving on. Now the thing is, just like in math, right, we have addition, subtraction, etc. We have a way to connect the propositions as well, right? And now we will be understanding that. So let's move on. Okay. So I've provided all the logical connectives for the table on the board, right? So I'm considering two of the propositions. He lives in Canada and he has a cycle, right? So the first very basic thing to understand is both of these are propositions. Why? Both of them have a truth value. So if some person, I've just written this general sentence, right? If he lives in Canada, then this is going to be true, else it's going to be false, right? And same thing is with this sentence over here. If he has a cycle, then this sentence basically is true. If not, then it's going to be false, right? So both of these are propositions that I have. And now we are looking at all the logical connectives. It's basically a way that I can connect them or make propositions, like changes in these propositions, right? Okay. So let's start with the first one, which is the negation, not P. Negation basically means not P, right? The negative version of the sentence. So let's try to understand this over here, right? I know that P is he lives in Canada. Not P would basically mean he does not live in Canada, right? So negation of P is going to be he does not live in Canada, right? So I hope you're able to understand it. He does not live in Canada. This is the opposite of he lives in Canada. But now think about this sentence. If P was he does not live in Canada, then its negation would be he lives in Canada, right? So it's basically kind of like, if you remember, the complement. Now, if you try to understand it, think about complement was the all the elements which are outside but not inside that set, right? This is kind of like the opposite of this proposition P over here. So I hope you're able to understand how this negation works, right? Negation is very simple to understand. One thing, just a general note, like basically the negation of P would simply result in the proposition P again, right? Okay, moving on. Let's try to understand what is conjunction. Conjunction basically means P and Q, right? So whenever you have two propositions, let's say I have he lives in Canada and he has a cycle, then its conjunction is going to be, we just add an and in between both the sentences, right? So what is going to be conjunction? This is going to be the symbol, right? So don't confuse both these symbols over here. P and Q is he lives in Canada and okay, so he lives in Canada. This was the first proposition P. I added an and in between and has a cycle, right? So this is going to be the conjunction. Now let's try to understand what does conjunction mean in detail over here. Look, whenever we use this condition and over here, what this basically means is that in order for this entire condition or logical connective to be true, both of these sentences should also be true, right? Let's try to understand this with an example. Let's say this statement was true, right? And this statement was false. Let's say there's some person, he lives in Canada, this is true, but he does not have a cycle, right? So Q, he has a cycle, is actually false. Now, when I try to form the conjunction, right, which is also a proposition, think about it, right? This is also going to be a proposition. This conjunction is either true or it is false. So he lives in Canada, this is true, this portion is true over here, and he has a cycle, but this portion is false. But what happens is, in conjunction, since this sentence over here is false, this entire sentence itself is going to be false again. What I mean is, in a conjunction, all the statements, all the propositions that I connect need to be true in order for the entire condition to be true. In this case, since this is true and false, this is actually going to be false in this case, right? Because there's one condition which is not true. Okay, but if I make one change, right? Think about it. If I make this change, and if I did, if this was also true as well, if both the conditions were true, then only in this case the entire proposition, which is their conjunction, would actually be true, right? Okay. Now, what if both of these statements are false? If both of them are false, then again, the entire conjunction is going to be false once again, right? So the basic summary of what conjunction is, in a conjunction, in an and statement, you have to make sure that all the conditions are true. If they all evaluate to true, then only that entire condition is going to be true, otherwise it's going to be false, right? You're going to be using this and condition a lot in coding problems. So for example, if you code in Python or in C or any coding language, we use and, or, and all these conditions a lot, right? So it's very important to have a good understanding about how they work. So I hope you understand how conjunction works. Let's moving on. Let's try to understand the disjunction now, right? Both of these are very similar with some very distinct difference in both of them. Okay, so this is P and Q, right? Now let's try to understand what is P or Q. Same again, just like in what we do is we add a or statement in between, right? So we add this or word in both the sentences. So P or Q is simply going to be he lives in Canada, or okay. So this is the first one and this is the second one. Let's try to understand how disjunction works. I'm just going to erase this portion. Okay, so I hope you understand how to form a sentence when it's a disjunction. You basically just add a or in between both the propositions. Now again, this P or Q is also a proposition, right? This is supposed to have a true or a false value. Now, when it comes to disjunction, what happens is we only want one of the conditions to be true, right? So what I'm trying to say is, think about it. If you try to read this sentence, he lives in Canada or he has a cycle. If either one of these is true, then this entire sentence is going to be true. If both of them are false, then only this entire sentence is going to be false. So let's try to understand with this example, right? He lives in Canada. Let's say this is true. And let's say this is false. So in the case where he lives in Canada is true, right? So he lives in Canada, but he doesn't have a cycle. We have he lives in Canada is true or false over here. So I have true or false, and whenever you have a disjunction in between, it always results in a true. Why? I only want one of these conditions to be true in order for this entire logical connective to be true, right? And in this case, since this condition over here is true, hence the entire condition is going to be true itself. But if I make a change, now if they were false and true, let's say if this was false and this was true, same thing would happen, right? Why? Because I only want one of these conditions to be true. So this is false or true is equal to true again. But what is going to be the condition in which they both are false? It's only possible. So if both of these conditions are false, right? If he does not live in Canada or he does not have a cycle, in that condition only, this entire sentence is going to be false again. So false or false is going to be false, right? So a quick summary of what is disjunction. In disjunction, when I'm using a or in between the two sentences, if you try to understand it, and even if you try to think about in just simple words, right? Or basically means that either this or that, right? Even if one of those conditions is true, then the entire logical connective is going to be true. If all of those conditions are false, in that case only, the entire condition is going to be false. Now, if you try to understand it and compare it with the conjunction, in conjunction, I want all the conditions to be true in order for the connective to be true, right? But in this one, I only want one condition to be true. And in this one, I want all the conditions to be false in order for this entire connective to be false. But in this one, I only want one condition to be false in order for the entire connective to be false, right? Okay. So I hope you have a good understanding about what is conjunction and what is disjunction. Moving on, let's try to understand the P then Q condition statement. Okay, moving on, let's try to understand the conditional statement, which is if P then Q. So if I have to form the sentence, whenever we have this arrow, right? So if you're given this representation P arrow Q, that means it basically translates to if P, which is on the left hand side, then Q. Right? So I'm just going to write down this sentence over here, right? Okay. So I form the sentence again. In this case, when the proposition P is he lives in Canada and Q is he has a cycle, the P implies Q would simply be if he lives in Canada, then he has a cycle. Now let's try to understand what this conditional statement means. This is a bit tricky to understand as compared to the first three, but it's going to be a super easy, right? So it's not going to be that complicated to be honest, right? So whenever I talk about if P then Q, what I'm trying to say is if P is true, then Q must also be true, right? So what the basic meaning of this sentence is, if P is true, then Q must also be true. Okay. So basically, if P is true, then Q must also be true for this entire condition to be true, right? This is the only condition that you need to remember, right? This is the only sentence that you need to understand. If P is true, then Q must also be true, right? So if he lives in Canada, then he has a cycle, right? So if this sentence is true, let's take an example, right? Consider that he lives in Canada. Now just think about this in normal way. Don't try to complicate these things, right? So let's say this is true and this is false. Now, according to this condition, right, if P is true, then Q must also be true. In that only case, that is the only case it's going to be false. So think about it. He lives in Canada, right? If he lives in Canada, that means this is true. Then he has a cycle. But since he lives in Canada and he does not have a cycle, that means this entire proposition is going to be false. Why? Because I need both these conditions to be true. Since this is true, then this condition should also be true. That is the main important thing to understand in the conditional logic, right? So just a quick summary once again. The left condition should be true. If the left condition is true, then the right condition should also be true. If that's not the case, then it is going to be false. But now let's take a look at the other cases that we have, right? Now, think about it. If both of them were false, if both these conditions were false, right, that means he does not live in Canada, then he does not have a cycle. We don't really care anymore. Why? Because we only care about if this condition is true. In this case, since this condition is false, right, we no longer care if this is true or false, right? So I'm just going to repeat this once again. If this P, which is on the left hand side, is false, then it doesn't matter if this Q is true or false, this entire condition is going to result in true once again. So false gives true is basically true. Now let's take a look at another example. What if both of them were true? If both of these conditions are true, right, that means he lives in Canada, then he has a cycle, then our entire condition is going to be true again, right? Because that's the basic thing we consider about. We know if P is true, then Q must also be true. And if this is true, then our entire condition is going to be true as well, right? So just a quick summary once again. You need to remember this sentence when you have a conditional statement for you. So if P is true, if you find out that the left side condition is true, then this side, which is on the right side, the condition on the right side should also be true. If that's not the case, then it's going to be false. In all other cases, this entire conditional statement would be true, right? I'm also going to be providing the truth tables, and I'll explain all these things just one more time to make things a lot more clear, right? But the basic idea is very simple. Okay, moving on, let's try to understand the biconditional statement. Now, if you have a good understanding about the conditional statement, which is if P then Q, then this should be a lot more easy to understand. In very simple terms, if P, if and only if Q means, I'm going to write this down over here. If P what I'm trying to say is, in the biconditional statement, I want both the ways to be true, which basically means P then Q should be true. Both of these conditions should be true for this biconditional statement. P if and only if Q means if P then Q, and the condition if Q then P, right? So I've written it down over here. So let's try to understand with this sentence over here. If I'm talking about, let's first try to understand how we write down it in the sentence, right? Whenever you see the if and only if statement, you need to understand that it is a biconditional logic, right? So if I'm given the double arrows, that basically means he lives in Canada. So this is how we basically represent the biconditional statement. But if I have to break this down, I get something like this, right? So I'm sorry for the bad handwriting, but what I'm trying to say is I have this biconditional statement, right? He lives in Canada if and only if he has a cycle. If I break this down, right, it simply means if he lives in Canada, then he has a cycle, which comes down to this condition over here. And if he has a cycle, then he lives in Canada. Basically, I want if P then Q and if Q then P, both of these conditions to be true in order for this biconditional statement to be true, right? Okay, so that's the basic idea. I'll further try to explain this biconditional statement when I introduce the truth tables. So let's try to understand all these conditions or symbols with truth tables, and I think it will make things a lot more easier to understand. Okay, so I've given all the truth tables on the board. I hope you're able to understand what this means, right? So this T and F, T over here means true and F over here basically means false, right? Now let's try to understand each one in detail. I've already explained how all of these conditions work, right? But I've provided the truth tables and I'll explain these as well. So starting with the negation, right? Just like I said, negation basically means the opposite of a sentence. So if a condition, let's say if a proposition is true, then its negation is going to be false, right? So let's say P to Q is okay. So what this basically means is negation is the opposite. So if the proposition P is true, then its negation has the false value, right? And if it's false, then its negation is going to be true. So if P, let's say he works hard, is actually true, then its negation would be he does not work hard, which is going to be false, right? Okay. So moving on, let's try to understand the conjunction. Now, if you take a look at this truth table, when both the conditions are true, then this entire conjunction is true. But in all the other cases, this conjunction is actually false, right? Why is this the case? Just like I said, in conjunction, I want all the conditions in the conjunction to be true, right? Over here, P is true and Q is true, and that is the only case where the entire condition is true. Whenever I'm using the and in a sentence, I'm trying to say that both of the sentences are true, right? So you need to understand this very basic logic. Now, in this case, where Q is false, this entire condition is going to be false again. In the case where P is false or both of them are false, the condition is going to be false once again, right? So quick summary, in and, I want all the conditions to be true in order for the entire condition to result in true, right? Moving on, let's try to understand disjunction, right? Now, if you take a look at the disjunction table, you see there's a very clear difference in both of them. Over here, there's 3 truth values and 1 false value. And in this case, I have 1 truth value and 3 false values, right? So in junction, you can see that when both the conditions are true, the entire condition is going to result in true. If one of them is false, it doesn't matter. Since I'm using the or in the statement, I only want one of the conditions to be true, right? So since as long as one condition is true, this is going to be true. But in the last case, since both of the conditions are false, that is the only case where this condition is going to be false, right? So quick summary of or. In the or sentence, or whenever I'm using or in a propositional logic, right, I only want one of those conditions to be true in order for the result to be true, right? Okay, moving on, let's try to understand the truth table of conjunction, right? Now, if you try to understand it, just like I said, in conditional statement, if P is true, then Q should also be true. That is the only thing that I need to remember, right? In the case P is false, then I do not care whether Q is true or it is false. So think about it, right? In the case where both the conditions are true, right, my entire condition is satisfied and hence this is going to be true as well, right? But when P is true, right, I also want Q to be true. But in this case, since it is false, this is the only case where this conditional statement results in a false, right? Moving on. Now, if you see the last two places, right, which is false true results in true and false false results in true. Why is this the case? Just like I said, I only care about when the condition P is true or not. In all other cases, since P is false, it doesn't really matter if Q results in a true or it results in a false. The entire condition is going to result in a true, right? So I hope you are able to understand it. Like even if I try to explain it with this sentence over here, right? Let's say if he works hard, then he will become a. Let's try to understand each one of these sentences, right? Each one of these conditions using this sentence. Let's say both of these conditions are true, right? He works hard, then he became a doctor, right? Then that is a good way, and this entire condition is true. He worked hard, and he became a doctor. So this entire sentence is going to be true in the case both the conditions are true, right? Just try to logically understand in just simple English, right? But let's say he worked hard and he did not become a doctor, right? According to our condition, if he works hard, then he should become a doctor. But since he did not become a doctor, this in this case it would be false, right? Now, if he does not work hard, then we don't care if he becomes or if he does not become a doctor. The condition, the entire condition is going to be true, right? So if he does not work hard and he still becomes a doctor, that's a good thing, and that is going to make the entire condition true. But if he does not work hard and he did not become a doctor, then again the entire condition is going to be true again, right? Okay, moving on. If you have a good understanding about the conditional logic, then biconditional should be extremely easy to understand. Biconditional is simply this combined with the conditional two times, right? So this is P, then Q, and Q, then P. Now, if you try to understand it, I want both these conditions to be true in order for this entire thing to result in true, right? Okay, let's try to understand this truth table from this truth table, right? So what I'm going to do is I'm going to use this truth table that I have, and I'm going to form all the values that I have over here, right? So this is equal to, okay, if P then Q and Q then P, then it is going to be equal to if and only if Q. So think about it, right? In the case P and Q are true, think about it, right? If this is true and this is true and this is true and this is true. Let's take the example where both of these are going to be true, right? If true, then true, entire condition is going to be true, and this is going to be true as well. So this is going to result in a true value. I hope you're able to understand, right? And same thing over here, right? In both the conditions where both the values are true, I get a true value, just like I've solved it over here. So now let's take the case where P is false and F and Q is true. So if I have if false then true and if true then false, what is going to be, right? Think about it this over here. If false then true, this is going to be true according to the conditional table, right? But when this is true, when the left condition is true and the right condition is false, then it is going to be, sorry, this is going to be true and this is going to be false. And if you understand the conditional, the conjunction, in conjunction, I want both the conditions to be true, right? I want this to be true and this condition to be true as well in order for the entire condition to result in true. But in this case, I have one condition false. So this is going to be false over here. I hope you're able to understand it, right? So just like over here, when one condition is false and the other condition is true, then the entire condition is going to be false, right? Okay, so moving on, same thing is going to happen for this one, just like this way I've solved it, same thing is going to happen. But now let's look at the last case, when both the conditions are false, right? So when both the conditions are false, I get false to false and false to false, right? Okay, let's take a look at this table over. When I have false and false, then the entire condition itself is going to be true. So this entire condition is going to be true and true. And since both the conditions in the conjunction are true, this is going to result in a true value, right? So long story short, what I did is I used this conditional table and I basically used this equation to form the biconditional table. So the basic point is that this is nothing but P then Q and Q then P combined into one, right? So I hope you were able to understand all these logics, right? Now I'll be giving a bunch of questions, and if you guys are able to solve it, that's pretty good. Okay, so let's start with question number one. Given the proposition P is Alice studies and given the proposition Q is Alice passes the course, consider the statement negation of P or Q, right? By now, I hope you guys are able to read these propositions, right? Just like in English. Now, my task is to complete this table. So I'll start with completing the table for negation of P and then completing the table for this portion over here, right? So negation of P is very simple to understand, right? Negation means the exact opposite. So if the proposition P is true, negation of P is going to be false. If P is true, it is going to be false. I'm just considering the parallel values in this case, right? So since this over here, this is false, this is going to be true, and this is false, this is going to be true. So I've completed this portion of the table. Now let's try to fill all these values, right? Okay, in the case where negation of P is false and Q is true, right? So false or true. If you remember the disconjunctions, we only want one condition to be true, right? So in this case, this is going to be true. Let's take a look at the second one. When both the conditions are false, the entire condition is going to be false. In the case where both are true, entire condition is going to be true. And again, in the last one, I have true or false. It is going to be true once again, right? So I hope you were able to solve this question. Moving on, let's try to solve question number 2. Which of the following statements are logically equivalent to, I should say, if P then Q, right? So once again, for this question, I want you guys to pause this video and make a table for all these three parts, right? And once you have the table for all these three parts, I want you guys to compare that table to the table of if P then Q. And what you'll realize is, I'm just going to give the answer now, right? This table, we have drawn it just over here, right? What my point is, if the truth values are actually same, then we say they are equivalent, right? So the basic idea is, if for all the truth values, if they are equal, then we say they're equivalent, otherwise they're not. What you'll find out is that negation of P or Q is actually in fact equivalent. This is the symbol for equivalence, right? I'll try to cover all these symbols in detail in the future lectures, right? But for now, just try to understand that this is the equivalent symbol, just like the equal to sign. This is going to be equivalent to if P then Q. And this over here, the part 2 is also going to be equivalent, right? So both of these are going to be equivalent, but the last one is not going to be equivalent, right? So now moving on, let's try to solve question number 3. Given 2 plus 2 is 5, start with the first one, right? 2 plus 2 is 5. I know that this either has one of two values, right? True or false. But in this case, I know this is actually going to be false, right? Why? Because 2 plus 2 is actually 4. But since it has one of the true or false values, this is going to be a proposition, right? Moving on, let's see what does 2 mean, right? It says clean your room. Now, clean your room, this sentence doesn't have a true or a false value. I cannot say that this is true or this is false. So this is not going to be a proposition in this case. Moving on, let's take a look at 3. If x is greater than 2, then x square is greater than 4. Now, think about this, right? When I told you if there's a variable and we don't have any idea about what that variable is, we say it's not a proposition. But in this case, if you take a close look, we have been told this variable x is greater than 2, right? If the variable x, we have been given what the value would be, then x square is greater than 4, right? So this actually is going to be a proposition, right? Because it has a true or a false value. So this is going to be a proposition. But if you remember, when I was trying to talk about x plus 10 is 15, in this case, this is not a proposition. Why? Because I don't know the value of x. But in this case, I have been told that x is a value which is greater than 2, right? That is why this is going to be a proposition. Okay, moving on. In 4, I've been given how old is Alice. Now, last one is a question, right? Question cannot be figured out as true or false. So this is not going to be a proposition as well. Okay, moving on. Let's try to solve question number 4. Let P, Q, R be three propositions such that P is true, Q is false, and R is true, right? I've been given their truth values. Evaluate the following expression, right? So if you remember the entire table, you should be able to solve this entire condition. So I'm going to start with this now, right? What I'll do is I'll replace each of these proposition words with their truth values, right? And that will make things a lot more easier to solve. So negation of P is true or Q is false, right, implies Q, which is false, or R, which is true, right? This is what I get. Now, let's try to solve each of these parts individually first. Whenever you have this type of an expression, try to solve, and you have a conditional statement in between, try to solve both the parts first, and then try to figure out the final solution. So I'm going to solve this portion first, then I'll solve this portion, and then I'll evaluate the entire expression. So this basically means false or false implies false or true basically means true, right? So this means true. False or false basically means false again. So this means false implies true. And if you remember from the truth table of the conditional statement, if the left condition is false, then we don't care about the right condition is true or not. So in this case, this is actually going to be true, right? So the final answer is going to be true in this case. So I hope you were able to solve all these questions. I think this has been a very long video, right? So but I hope you were able to understand all these concepts in detail. And in the next lecture, you will move on and cover some more concepts, right?